Here are solutions to homework set number 3 for ECE 476-676 Advanced Embedded. In this homework, we're looking at binary inputs, binary outputs, and serial communication with a Raspberry Pi Pico. The first problem is build yourself a $32 AND gate or OR gate. Read two push buttons, GP15 and 14, and with that, generate the logical AND on LED 17, exclusive OR on LED 16, 17. So in terms of coding, I am going to import pin from machine, sleep from time, assign A and B, those are my inputs, to pin 15 and 14, both with pull-up resistors, assign the LEDs to variables D16, D17, those are my LEDs, and beeping just for fun. I don't actually use it. Then forever and ever, I'm going to read or output the diode 16 is A and B, 17 is A exclusive OR B, and then print the values so you can see what's going on. Okay, so to see what's happening, let's run this code. This is A and B, A exclusive OR B. So if I push the button, I get a 0. I only get 1 for A and B if both inputs are 1. If either one's a 0, I get a 0 in third column. For exclusive OR, that's even odd. So here's an even number of ones, odd, even, odd, odd. And you can see that with the LEDs as well. So here's 16, 17. This is 0, 0, output 0, 0, 1. There's exclusive OR and 1, 0, 1, 1. Problem number 1. Problem number 2. Write a Python program that uses the push buttons for an input of a number. Every time I hit 14, it counts by 1. 15, I count by 10. So again, I define the buttons to be inputs. I'm going to call it B1, B10. Here's my LEDs for no reason other than I am reusing old code. Starting from 0 with a flag of 0. Forever and ever, do the following. If I hit button 10, then I count by 10, set the flag, and wait till I release. If I hit button 1, count by 1, set the flag, wait till I release. If the flag is set, then print the count. So there I only print whenever I press and release the button. What that looks like. Switch over to problem 2 and run it. So it's waiting for me to hit and release the button. If I press the right button, press release, it's counting by 1s. Press and release the left button, I'm counting by 10s. So this is one way to get numbers into the Pico. Use the buttons, and to make it more convenient, like when I input the number 300, okay, 310, I can be counting by 10s. If I had more buttons, I could have the hundreds, thousands, and so on. I can read push buttons. Problem 3. Let's build a combination lock. In this one, I'll have a shift register. That is my guess for the combination. The Pico generates a random number, and I guess what it is. Every time I hit button 15, that's my guess. Try the key, and it's going to tell me if I'm high, low, or just right. So the first part is come up with a program that generates a random number for the key. So that's what this program does. It imports rand range from random. Pick a number between 0 and 255. That's my key. To test it, I'm going to generate 5 random numbers. And they're all between 0 and 255. Yeah, it looks kind of random. Problem 4. Write a program that reads the shift register. So a couple ways of doing that. I'm using the SPI function. I'm going to have a baud rate of 10,000. If it gets too high frequency, all the wires off my board start giving false readings. Polarity and phase, got to get these right. What I want is the clock line to start high, go low, like this. That's the polarity 1, starts out high. The data shifts on the rising edge. Erase that. Shift on the rising edge, read on the falling edge. That's where you get the phase. Assign latch to pin 10. Beeper is still left over from old code. Here's the subroutine. I'm going to pulse the latch low then high. That reads the data. I will then do the serial port read. This is the data I'm stripping out, which I don't use. Reading 1 byte. Return the ordinal value of the data. Then I'm just going to read the serial port over and over again. So when I do that, okay, so to check the code, what I can do is down over here. That's my shift register being read by the Pi Pico. If I bring over an oscilloscope, now basically oscilloscopes are your friend. They can kind of show you what's going on. Glare, however, is not my friend. So there you can see what's going on with an oscilloscope. As I change the values, moving the wires around, I can see the clock line and yellow staying the same. The bottom line is the data line. So I'm going to output some 0 zeros. So move the pins around. The data is changing. And also what I read comes in is different. So that is problem 4, reading the shift register. Problem 5 is now write a program that has you try to guess the combination. So what I'm going to do is first generate a random number. I am then going to keep on looping until I'm correct. It's going to have me hit button 15. When I do that, it's going to read the shift register. Tell me if my guess is too low, too high, or just right. So running that in Thani, here's my first guess. My guess was too high. So I'm going to move the buttons around. So I'll move the first wire, and it says 80 is too low, or too high. Move the next one over, and tells me that 40 is too low. Next bit, 60 is too low. 70 is too low. And eventually you get the right message and got something wrong here. But anyway, that is homework set number 3 for Advanced Embedded.